So in this video we're going to discuss about Dalton's law of partial pressure. So Dalton's law of partial pressure states that the total pressure of the mixture of ideal gas is the sum of partial pressures. So consider if there are several ideal gases and mixed together in a vessel, then the total pressure of the vessel is equal to the sum of partial pressure. So partial pressure is the pressure exerted by the particular gas if only that gas is present in the vessel. For example, consider if it is in a vessel there is a mixture of three gases A, B and C. So the partial pressure A is equal to pressure exerted only by A, and considering B and C are not present. Similarly, partial pressure of B is equal to pressure exerted only by B, and considering A and C are not there. Similarly for C. According to Dalton's law, the total pressure of mixture is the sum of partial pressure of A, partial pressure of B and partial pressure of C. Okay, to show how perfect gas equation concludes Dalton's law of partial pressure. Suppose let us take a mixture of gases, which means gases do not interact with each other. By perfect gas equation, PV will be equal to mu RT, where V is volume of vessel and P is pressure and T will be temperature. As these are mixture of gases, so we can say that PV is equal to mu 1 plus mu 2 into RT. So P is equal to mu 1 mu plus mu 2 RT by V. So it will be like mu 1 RT by V plus mu 2 RT by V. Just multiply RT by V inside the bracket so that the total pressure will be equal to the sum of the partial pressure. So the total pressure due to the mixture of gases is equal to the pressure of partial pressure. So you can see the figure also. Pressure of gas A is P1, pressure of gas B is P2, and pressure of gas C is P3, and the total pressure A plus B plus C will be equal to P1 plus P2 plus P3. Okay, yes. So coming to the next topic, that is pressure of an ideal gas based on kinetic theory, that is assumptions. So let us consider a cube shaped container filled with an ideal gas. We will consider only one molecule. The molecule hits the walls of the container and bounces back. So let the velocity of the molecule when it is coming be Vx, Vy and Vz according to the coordinates. When the molecule bounces back, the velocity will be minus Vx, Vy and Vz. So the change in momentum will be equal to final momentum minus initial momentum, so which is minus mvx minus mvx is equal to minus 2 mvx. So this change in momentum is imparted to the wall due to collision. So momentum imparted to the wall in collision by one molecule is equal to 2 mvx, but as there are many molecules, we have to calculate total momentum imparted to the walls by all of them. To calculate the total number of molecules that hit the wall, so area of the wall should be considered, therefore, and also you have to consider the time all molecules within the distance of A into Vx into del T can hit the wall. This means all molecule and time del T lying within the volume A Vx del T can hit the wall, but on an average half of molecules move towards the wall and half away from the wall. Therefore 1 by 2 A into Vx into del T will hit the wall. So therefore number of molecules that hit the wall will be equal to number of molecules away from the wall. So total molecules that hit the wall will be equal to 1 by 2 n into A Vx into del T. So therefore the total momentum also will be changed to 2m Vx Vx into 1 by 2 n into A Vx del T. So after simplifying, total momentum will be equal to A n Vx square del Tm. So force exerted on the wall is equal to rate of change of momentum, and these things has to be noted down. And additionally the pressure of the wall will be equal to F by A. So we are calculating pressure here, so n m Vx square. So totally it will be like P is equal to n m Vx square. So this is very true for group of molecules moving with velocity Vx. So you have to definitely note these points. That is very important. All the molecules inside the gas will not have the same velocity. All will be having different velocities. So the above equation will be valid for pressure due to the group of molecules with speed Vx in x direction, and n stands for the number density of that group of molecules. Okay, so these things has to be concentrated. Okay, so Dalton's law and pressure of an ideal gas based on kinetic theory. Okay, so thank you.